Hi, difference of squares. So this is lesson 6, and it is the difference of squares, and hopefully you will soon find out why we call it difference of squares. You will hear this in algebra used all the time, and what we are doing to find difference of squares is we are trying to find the factors of a polynomial, meaning we're trying to find two or more different things that when we multiply them together will create a term or a polynomial, if you will. Okay, so this is all about factoring and breaking apart big strings of monomials. And here we go. So again, I'm starting with the class notes. And if I scroll up a little bit, oh yeah, maybe I should do it like that, right? Okay, oh yeah, I need to back up a little bit. You might notice that I have a square minus a square because it's the difference of squares. It's if I subtract squares, which is literally what I'm about to do. So here we go on the top. So we're simplifying the following polynomials. So this is a little bit of review to make sure you understand that I have, when I multiply binomials together, remember I can do FOIL, right? If I needed to multiply these together, I can FOIL it. I can FOIL this too, and I can FOIL this too. These are all binomials that I'm multiplying together, and I'm distributing. I'm using the distributive property to make sure that I get the right answer. So here we go. If I have x times x, I have x squared. And then I have negative 4x, positive 4x. See, I have negative 4x and then positive 4x. And then last but not least, 4 times 4 is 16. My pencil is breaking. Okay. So then if you simplify this term, some of you were noticing this. When we did some problems in class the other day, you noticed that the internal terms were usually like terms. And that's kind of the way it worked out when you distributed these binomials together. These are like terms that I can combine. So you guys practice a lot of that. Well, if you notice here, I have opposite numbers. I have negative 4x and I have positive 4x. When I combine these, and these are special terms we're going to find out, when we combine these go away. They become 0. Negative 4x plus 4x is 0. So I'm left with x squared minus 16. If I look at the answer here, x squared is my first term. That is a square number if you think about it, because it is x squared. 16 is a square number, even though it's a negative sign, right? That actual number 16 is a square number. Isn't that interesting? It's going to come back to us. But let's go ahead and FOIL out the other two. So if I FOIL out these two, I have 25m squared minus 5m plus 5m. And then I'm going to subtract my 1 at the end. And you're going to notice that I have my opposites again, negative 5m, positive 5m. So they go away. They become 0. So I end up with 25m squared minus 1. Think about 1. 1 is a square number. It's also a cubed number if you think about it. 1 is a very special number for many respects. Let's FOIL this last one. I have 4a squared minus 6ab. Remember, a comes before b, so I have to make sure I put it in the right order. 6ab, right? And then at the end, I'm subtracting, so I have 3 times negative 3, and then I have b squared. Okay, so I have negative 9b squared. So I assume you're going to notice opposites in the middle. Opposites are meeting, and then they're going to go away. So this becomes 4a squared minus 9b squared. all of these numbers are square, and my operator is a subtraction sign. So that is what we call a difference of squares. So square minus a square number is something special. Difference of squares. So this is a review if you think about it up here, but then we're going to deconstruct these terms. We're going to try to take these terms and try to put it back in this form of, in essence, what two binomials, when you multiply them together, when you FOIL them together, what will result in these answers. So we're starting to work backwards if you think about it. Okay, let's go. So here are some tips. You have to make sure you have a difference of squares. So when we start doing some of the classwork, we are going to make sure that we have two square numbers in both positions, okay? There has to be a subtraction sign. You have to be able to get the square root of both of them, okay? So if I just think of, let's see, what if I do p squared? Well, I already know that's a square number, and then I have to have a subtraction sign, and then pick any square number. Let's do 100. I like 100. That is a difference of squares, okay? If it helps you to draw a little square around, for some people who like the visuals, you can do it. Use the following rule to factor. So again, a squared minus b squared equals, well, if I think about that, that's a square number, and that's a square number. How I get that, and you might notice this, a plus b. Well, if I look back up here for a minute, do you notice that my first binomial or factor, if you think about this, these are both factors of this product. Do you see I have a x plus 4 and I have an x minus 4? Well, that's interesting, and I end up with the negative 16 here. 5m plus 1, 5m minus 1, I end up with a negative. So if you notice all of these problems up here, that the first factor, you are adding those two numbers together, or the terms together, and then the second binomial, you're subtracting the two terms together. So if I look at my rule, because I'm coming up with a rule here, well, if there are two square numbers that I am subtracting, then my rule is that my first factor is I take the square root of one, I add the square root of another. My second factor, or the second binomial, is the same idea. I'm taking the square root of each term, and then I am subtracting them. Now we can check to make sure that that actually works. So let's FOIL this out again. So if I think about it, a plus b times a minus b, let's just make sure. The beauty of distributing and factoring is that you can always check your work. So you should really never get the wrong answer if you check your work, or if you know how to check your work. That's half the battle. So make sure you FOIL it out, and I'm going to end up with a squared. Well, let's see. And then I have a times negative b, so that's negative ab. And then I have b times a, but remember I always write it in alphabetical order. And then I have b times b, right? Minus b squared. So let's see. Now what should happen in the middle is that I have these like terms, and they should be opposite. They're going to cancel each other out, and I'm left with a squared minus b squared, which matches our original problem. Okay. So let's go for it. We are, again, the goal is to factor the differences. If you're wondering, because I'm sure some of you are, I hope that some of you are, this does not work if you have the sum of squares. For example, if you have x squared plus 81, you cannot use this method, the difference of squares, because it's not a difference of squares. If I take x squared minus 81 though, Well, I think of these are both square numbers, so I can take the square roots of them. And then I can do the plus minus thing, right? Okay, so let's go ahead and start proving it. I have a squared minus 4. I feel like when the lights are on. Okay, first of all, are they both square numbers? Well, I actually, if it's square, great. They are both square. Now, what is the square root of a squared? So if I think about it, the square root of a squared, if you think about it, is, well, it's just a. If I think about the square root of 4, meaning what number times itself is 4, that is 2. So now I have some factors that I can play with. So here we go. So let's write our parentheses. I'm going to take one of the roots, a, and I'm going to add the other root, a plus 2. Okay, so again, I just took the roots and I'm adding them. And hopefully you're thinking to yourself right now, oh, okay, so then the next binomial or factor, remember this is one factor and this is another factor of this answer. If you think about it, we're working backwards, would be a minus 2, okay? And again, I could distribute it out to make sure I got the right answer. That would be that. Okay, so let's move on. So now I have n squared minus 64. You're going to see a lot of square numbers here because that's the whole point. These are both square. N squared, well, the square root of n squared is n, and the square root of 64 is what? Well, it should be 8. So now I have my roots, my square roots. Now I'm going to write them out. So I should have 9, now n plus 8, and then n minus 8. So when I do the difference of squares, I'm going to end up with one factor, the square roots, that I'm adding, and the square roots I'm subtracting. It's kind of cool, actually. Let's go for it. So now I'm just going to start writing, let me see, square root of 81 is 9. Square root of x squared is x. Okay, does it matter the order in which you add? No, it doesn't. So I'll just do it the order in which it came. So there we go. Okay. In this circumstance, the order is going to matter if you're subtracting that x. Just keep that in mind. So square root of c, and now I'm just going to write the square root right underneath because I think I'm getting a hang of it. So I have c and I have 10. C plus 10, c minus 10. And let's look here. Well, I have k squared plus 25. Oh man, my lights just went off. Okay, I have to do some adjusting. Well, here, let's do, first of all, these are square numbers. So conceivably this should work, but this is a problem because you now have a sum of squares, and we just over here defined that this sum of squares will not work. So this we would actually write prime. Okay. I'll do a couple more and then I have to teach you part 2 to this. Oh, 1, that's kind of fun. So 1 is a square number. I have a difference and I have 49y squared. Oh, that's square too. So the square root of 1 is 1. Square root of 49, well, the last time I checked, 7 times 7 is 49. And then I have y, because y times y is y squared. So 7y squared is all that stuff. So now I can just add these together. 1 plus, oops, I got ahead of myself. 1 plus 7y, and then 1 minus 7y. And if you do it in this right order, you should just plop in the plus and minus. Okay, hopefully that helped. I'm going to go on to the next page, okay? On the next page. So now I have something a little bit different. So I'm going to have to be a little more, dare I say, creative with this, because let's analyze something for a minute. So now we have examples called with a greatest common factor. So what I'm doing here is I'm looking for a bunch of things. I'm looking for a common factor, okay? Then I need to find the difference of squares. So there are a couple things I have to make sure I understand, and then I can check my work by distributing. So let's go for it. Well, first of all, I know that 2 is not a square number, but n squared is a square number. 72 is not a square number. So maybe, what would happen if I pulled my 2 out? I want to extract my 2. I want to just get it out of there. If I get it out of there, maybe I'm going to get a square number here. So let's try it. I'm going to extract, because I am a minor, I'm going to take my 2 out. If I take 2 out, because it's my greatest common factor, well, 2 times what number is 2 unsquared? Well, that would be n squared, okay? And then I have the idea of, does 2 go into 72? Well, it does, because half of 72 is 36. So let's just check our work. What I did here is I got my greatest common factor. I found a coefficient that goes into both terms with nothing left over. It's neat. Well, what's interesting here is that now I actually have a difference of squares. So I can actually factor this out even more, which makes it pretty fun. So I'm going to hold on to my 2, okay? And now I am going to write here my square roots. Okay, so I have n is the square root of n squared, and I have 6 as my square root of 36. So I have my 2 roots, so now I can have my 2 expressions, my 2 binomials. So I can do n plus 6 and n minus 6. Voila. That is now factored out. There's really not a lot more I can do with that. Now if I look at 22, so let's first look at the coefficients, because they are not square numbers, I know that. So I'm going to find the greatest common factor. Well, I know they're both, and I could go back to this method, right? I know they're both divisible by 2. Let's just try that. I'm going to go for it. Well, I don't know if you remember this, but if I put my greatest common factor over here, right? Well, I won't do that. Scratch that. Okay, I'm going to just pull my 2 out. Okay. If I pull 2 out, well, 2 goes into 18, or I did it like that before. Actually, I will do that on second thought. 18 divided by 2 is 9. X squared divided by 2 is, well, still x squared. I'm not doing anything to that term, right? So 9x squared. And then 50 divided by 2 is 25. Great. Oh, wow. So now I do have a difference of squares. I don't know what that was. Oh my gosh, I just erased it. I'm such a dork. Oh my goodness. Okay, now I have a difference of squares, so I can now keep factoring this. Okay, so I'm going to have to put this in a box when I'm done, but here we go. So I have 2. Now I'm going to look at my my terms here. I know that 3 times 3 is 9, and x times x is x squared. And then the square root of 25 is 5. So here are my square roots. So now I have my terms that I need for my binomials. 3x plus 5 and 3x minus 5. So I got my difference of squares, and then I have my factor. Okay, let's go for this one. So again, I'm first trying to extract my greatest common factor. So if I think about my factor, I think that, let's try 2. I'm going to try 32 and 18. And let's do the greatest common factor. I think, yeah, we're going to try 2. So I can put the whole thing over 2. Again, what I'm doing is I'm pulling out the factor first. So if I have 2 outside, and then inside my initial is going to be, well, 32 divided by 2 is 16. S squared left over, minus sign, 18 divided by 2 is 9, and then I have u squared. Okay. As you can imagine, difference of squares. I can get the square root. This is 4 times 4 is 16, and then s times s is s squared, and then I have 3u is the square root of 9u squared. So now I can I forgot to put this in a box. Shame on Botanic. so now I can do my difference of squares here. So I'm going to just keep my 2 because that was my original factor. And then I can put these terms together. 4s plus 3u, 4s minus 3u. Okay, and then you can put that in a box. Okay. Let's go down to something that looks, let's go down to 27. 27 is kind of fun. Okay, because I see a 4th degree or quartic binomial. So let's do this one. Well, first off, I know that 5 goes into both of these because I know my 5s and 0s, if numbers end in 0 or 5, I know that 5 goes into them. So let's just write my 2 coefficients here, and I'm going to say that 5 is my factor, greatest common factor. So I'm going to divide it all by 5 to find my other factor. So let's take 5 outside. But there is something more. So remember, it's not just a coefficient. If you see that there is also a variable that fits into both, then you're going to take the variable to the lowest degree, and that's also a factor. So I can say that n squared fits into both n squared and n to the 4th power. So this is why this one's interesting. So now I have 80 n to the 4th power divided by 5 n to the 2nd power. Well, 80 divided by 5 is 16. But you might be thinking, but what happened to the n squared here? So I'm going to write this out, and then I'm about to fix something in just a minute. Actually, I'll fix it now. I just don't have find another eraser. Over here to the left, when I factored this out, remember this has to match what you put outside. So this is actually 5n squared. And then I have 16n squared minus, so 125 divided by 5 is 25. And do I have any variables left over? N squared divided by n squared? No, we're done. Okay. Well, this is interesting, right? Because this is also a square number. Don't worry about that, though. I have this to contend with. This is the difference of squares, because of 4 times 4 is 16, and then n times n is n squared, and I have 5 is the square root of 25. So now we can rewrite this. Oh, okay, 5n squared, 4n plus 5, hopefully you can read that, 4n minus 5. Okay, let's do 32. Let's try it. 32 will be the last one. Then I have to do some other homework, right? Okay, so here I don't have any coefficients. But I see an m and I see an n. So really, I can think about this is that mn is my greatest common factor because it's in both. So pull out, extract your mn. And again, you can put it over here, if that helps. And then I'm going to end up with m squared, because I'm just dividing this term by this term. Minus, well, mn over mn is just 1. So m squared minus 1. And this is so fun, because this is also, these are both square numbers. So I have, my square root is m and 1. So I have mn outside, m plus 1, m minus 1. Let's go for the homework. Oh, it says check your answers using FOIL. Okay, so again, the homework is homework number, if I go to the top, 6. The difference of squares. Okay. Let's go for it. So if I look at number 1, are they, so again, I want to make sure that I have both numbers, or terms I should say, are square numbers. So you can check that. Do you think that's true? I do. I think it is true. So I have x squared minus 36. So I'm just going to write them down here. I have x and I have 6. And it's a difference. So I can do it. Great. A squared, b squared minus 100. Yes, they're both square. If I square AB, if I square 10, I'm going to get that following answer. And I'm going to end up with this. Number 3, they're both square numbers. I have 4y and I have 5, or the square roots. So I end up with 4y plus 5, 4y minus 5. Number 4, hopefully you can still see that. Number 4, I have y and I have 7, right? Oh man, but look, because you know I try to trick you, but this is not the difference. So this, primaroo, okay? That's prime. You actually can't factor it out. 9a squared, oh, that looks good. 3a, and then 121, that looks good. It's 11. So now 3a plus 11, 3a minus 11, and make sure I put them in parentheses. 196, the square root of 196 is actually 14, in case you didn't know that. And I've got x. And I've got a difference. 14 plus x, 14 minus x. Number 7, the difference, and I've got squares. I've got 2y, I've got 9, 2y plus 9, 2y minus 9, parentheses, parentheses, I got 6c, I've got d, that isn't d, just so you know, d squared, in case you can't see it. So that's going to be 6c plus d, and then 6c minus d. Let's see, we have 4m, and I've got a p. I've got a p! 4m plus p, 4m minus p, m, 8n, m plus 8n, m minus 8n, 1, 2a, 1 plus 2a, 1 minus 2a. So you can probably see this pattern. It can go pretty quickly. 9b squared, and then 10. Would be 3b squared plus 10, and 3b squared minus 10. Okay. So down here, we're factoring them out. I'm only going to do a couple. And you're on your own for the rest. Hopefully, this is making sense. So I've got to do my GCF first. I'm going to pull out some factors. So right here, I'm going to pull out my 3, okay? So if I pull out my 3, well, I've got 3, and then I've got p squared, and then 75 divided by 3 is 25. Now I have a difference of squares. I've got p, I've got 5. So now this becomes, I have to write smaller, 3, p plus 5, and then p minus 5. I'm going to write it a little better. Okay. I'm going to factor out, I'm going to pull out my 5. So 5, x squared, I got left over, 18 divided by 5 is 16. Now, I think this is better, equals, I haven't boxed any of my terms, shame on me. I've got x, I've got 4, so I've got x plus 4, x minus 4. 7, I'm going to pull out my 7, so all over 7. So 7, pull it out. I got my n2 left over, and I've got 7 divided by 7 is 1. These are both square numbers. I've got n and I've got 1, so 7, n plus 1, n minus 1. Maybe I'll do 3 more. 16 and 100. Let's see, how should we attack that? Well, what if I pull out, well, I have to look for the number, right? I know 4 goes into the coefficient. So I'm going to write this, and I've got 4. It goes into both. I also have an x, and x is in both terms, and I have one of them. So I'm going to say that 4x is going to be my factor I pull out. So 4x, and I'm going to put it over 4x. If I think about all 16x cubed over 4x, I end up with 4x squared minus 100x to the, what is that? it can't even see that. Oh, it's nothing. It's x divided by x. So it's just, oh my goodness, just 25. Okay. Then I have 2x, and then I have 5. So then I have 4x, 2x plus 5, 2x minus 5. Voila. I'm almost there. 3. Let's pull out 3. Can I pull out any variables? Nope. It's just 3. So I'll pull it out, and then I've got x squared left over, and then I've got a y squared left over, and that is, difference of squares, 3. X plus y, x minus y. What about here, 18? I can pull out, let's see, 8 and 18 are both even. Let's just try. Oh, we're gonna go for 2. But do we have any other variables? Nope, different variables. So it's just gonna be 2. So pull out your 2. All this over 2 is 8 divided by 2 is 4. A squared left over minus 9b squared. And these are both square numbers. So I've got 2a and I've got 3b. 2a plus 3b. 2a minus 3b. And that's all I can do. Good luck. You're awesome. Oops, I almost just dropped the computer. Bye.